Hello everyone. So again we are meeting. This is first time we are taking concept-wise classes. Like initially I will start for inductive effect and it will be benefited for our 11th class, 12th class. Okay, it will be benefited for 11th class, 12th class and those who are preparing for NEET, JEE Main as well as the state SET exam. Like suppose Jharkhand is now going to be announced for JET exam. For that also it will be required. So this concept, it is very much required for your organic chemistry. So without this effect, like inductive effect, from where it came, it is came from your electronic displacement, right? This is topic came under displacement, electronic displacement, right? So when the electron is getting displaced from one position to other position, that uh, that effect directly caused by inductive effect or electromagnetic effect or resonance effect or hyperconjugation, right? So in that, first we are going to start this inductive effect. So what is inductive effect? This is a type of electronic displacement where the electron is getting displaced, right? So for that, what is minimum basic requirement? What is basic requirement? There should be a bond. Okay, there should be a bond, and that bond should be a polar nature. Polar nature, it means there should be electronegative difference. Electronegative difference. Without this electronegative difference, it won't be showing inductive effect. Means if there is no electronegative difference between this bond A to B, then the electronic displacement won't happen. Like what is that electronic displacement? Suppose this is a bond between A and B, and we are saying that electronegativity of A is greater than electronegativity of B, then what will happen? This this bond is having the pair of electron. One is from this A and another is from this B, because this is a covalent nature. This bond nature is covalent nature. So there will be a mutual sharing between A and B. But if the electronegativity of A is greater than electronegativity of B, what will happen? Those pair of electron will be shifted towards somewhat A side. Both the electron will be shifted towards A side, and it will be look like your the polarity will be shifted like this. This side will be slightly positive, and this side it will be slightly negative. So we can show it like delta positive, and here we can show it delta negative. Okay, so what is the delta positive and negative? It is a partial positive charge it is developing here, and partial negative charge, because both the pair of electron is towards A, right? So here then this inductive effect will be starting, because the electronegativity difference is present here, the bond is already here, and it is also in polar nature. The polarity is developed, delta positive and delta negative. So here likewise the electron inductive effect has started. So for example, if we take your CH3, CH2, CH2, and then suppose we are taking chlorine. So we know that in a periodic table, if we are going from left to right, the electronegativity is increasing, and from top to bottom the electronegativity is getting decreased. So we know that here that carbon is somewhere here in group 14, and after going group 15, group 16, group 17, the fluorine is there, below that chlorine is there. So it is like from left to right we are going, from left to right we are going. So in that, what will happen? The electronegativity is getting increased, right? So in this case here it will be delta negative, and then this one will be delta positive, right? So what is happening? This pair of electron is pushing towards the chlorine side, and here we call it minus I effect, right? We will discuss it. We will discuss it. What is minus I effect? What is plus I effect? But for this example, this particular example, we are saying that here it is minus I effect. It means electron withdrawing tendency, right? So chlorine is having this electron withdrawing tendency. Why it is having electron withdrawing tendency? Because according in a periodic table, what we could see, the chlorine is towards the right hand side, and we know that from left to right the electronegativity is getting increased, and if electronegativity is more for the chlorine, what will happen? It will pull that pair of electron towards itself, and when it will pull the pair of electron towards itself, what will happen? In carbon it will be developing that positive charge. Now to neutralize this positive charge, what this carbon will say? This carbon will asking help from the second carbon, please help us. So again what will happen here? Also one minimum delta positive, like it is very less, very less positive charge here developed, because it is also releasing its electron towards this CH2, because here the electron density, it is already shifted towards chlorine. Now what is happening here? Also somewhat positive charge got developed, okay, slightly positive charge got developed, and but this magnitude is very less compared to this CH2. Now what will happen? This CH2 will also, this carbon is also asking help from the nearby carbon, and it will say that okay, you just shifted your uh, positive charge, yes, you shifted your electron density towards me so that I could be a stable. So what is happening here? Also it's developing a very small positive charge, and it is giving its electron density to this carbon. And going forward we will see that this inductive effect is only exists till 3 carbon, right? Till 3 carbon. After that, after the third carbon, it will be vanished. Okay, from fourth carbon, fifth carbon, it won't exist. Fourth carbon, fifth carbon, it won't be exist. See here, this is 1, this is 2, this is 3. So till third carbon, this inductive effect will be existing. After that, beyond that, it won't be exist. Correct. So these are the some basic things where the inductive effect we are going through. But the minimum condition, what condition it is required for the inductive effect, or we can say the condition, or we can say the characteristic. Okay, whatever the things you want, you can say it. Whether the you can say conditions for inductive effect, or we can say characteristic of inductive effect, right? Both will be similar. First of all, we know that there should be electronegativity difference, right? There should be a electronegativity difference. Electronegativity difference should be there, okay, between the bonded pair of atom. Between the bonded pair of atom, there should be electronegativity difference. Suppose A and B. So there should be electronegativity difference between A and B. Either it will be electronegativity of A will be greater than electronegativity V, or we can say electronegativity of A is smaller than electronegativity of B. Anything, but there should be electronegativity difference. This will be the first condition, or we can say it a first characteristic. And we know that it is a permanent effect. Okay, it is a permanent effect. Correct. This one is a permanent effect. Why permanent effect? Where like till the time this bond will be there, this effect existing, right? Because if electronegativity difference is there, always it will be like the shifting of electron, like complete electron won't be shifted, but it will be towards the more electronegative side. So this is a permanent type of effect, right? It is not a temporary. We'll see that where the temporary effects are working and where the permanent effects are working. So in that, this inductive effect is a permanent effect. Why? Because it is based on the electronegativity difference, and till that electronegativity difference exists, this effect will be existing, right? So by that we can say that it is a permanent effect, right? And we we are saying that here what is that partial charge is getting created. Partial charge is getting created. How the partial charge is getting created? Suppose this is A and B, and now our A is having more electronegativity, then both the electron will be shifted towards A. We can say this is partial negative, this one is partial positive, right? So likewise, okay, likewise it is like this will be operated through only sigma bond, right? This will be operated through only sigma bond. There is no required for pi bond, right? It will be operated through only sigma bond. If sigma bond is there, it will be we can say that inductive effect is working. If sigma bond is not there, there won't be any inductive effect working. right? So now, uh, when we are seeing that first condition itself is electronegatiivity, so we'll see that how these electronegativities are working. Okay, how these electronegativities are working. Let's see. The first, we know that from left to right, if we are going, the electronegativity is getting increases. If top to bottom, if top to bottom we are going, electronegativity is decreasing. This is in periodic table, right? So this is in periodic table. Apart from that, what is the role of electronegativity? How we are going to calculate for electronegativity? Suppose in hybridization case, if it is sp, then sp2 and sp3, we have seen that this sp is having more electronegativity than sp2, and this sp2 is having more electronegativity than this sp3. Okay, why it is happening? Because here the percentage as character is 50. We will write here percentage as character. It is having 50%. Then this one is having, if we are calculating for sp2 here, what is the percentage as character? Here the percentage as character is 33.3. Here the percentage of S character is only 25%. So as the percentage S character increases, your electronegativity is also getting increases. So directly we can write percentage S character is directly proportional to electronegativity. So if percentage S character increasing, electronegativity is also getting increasing. And if electronegativity is getting increasing, the minus I effect will be getting increasing, because it will be pull the shared pair of electron towards itself, right? So that is the case. This is one thing. Even in hybridization, we have gone through with that percentage as character and the bond angle, right? Percentage as character with the bond angle. If percentage as character increases, your bond angle is also getting increases. If percentage as character is getting increases, your bond angle is also getting increases. That we have already seen in hybridization. If you required for that hybridization explanation also, you can ask me in the comment box. That next class will be hybridization, on the hybridization. I will take those hybridization and it will be like very fine for you. You will get to, like, you will be getting understand why hybridization is taking place, what is the meaning of hybridization, and how this percentage as character is we are, how this percentage as character we are calculating here, and how it is getting relation with electronegativity, how this percentage as character is getting related with bond angle, right? So now here we will see percentage. If percentage as character is getting increases, then your bond angle is also getting increases. Here we can see sp, what is the bond angle? 180. sp2, what is the bond angle? 120. sp3, what is the bond angle? 109.5 degree, right? So now you just see here percentage as character is 50, so bond angle is 180. Percentage as character decreased somewhat, bond angle is also decreased. Percentage as character is further decreased, bond angle is further decreased. So directly we can say percentage as character is increases, your bond angle is also getting increases. It means percentage as character is directly proportional to electronegativity, and percentage as character is directly proportional to your bond angle. Okay, so directly we can write it is directly proportional to your electronegativity also. Bond angle is directly proportional to your electronegativity also. If bond angle is more, your electronegativity will also more. So this will be benefited to solve our problem, right? Even one more thing is there that we will discuss when the problem is arises. Okay, that time we will discuss it. So now what will happen further, we can directly take the examples, or before that if you want we can write it and give it to you, that what is the plus I effect. Okay, plus I effect is electron releasing tendency. Okay, electron releasing tendency. Okay, or electron donating group. We can write electron donating group or electron releasing tendency. This is a plus I effect on, and order. We have to see what is the plus I effect order. So somewhere we can see it. It's like O minus is having greater than. Then you will see CS3, CCS3, tertiary. Then we can set secondary. Okay, then we say secondary. Then we say primary. Okay, then your tritium. Okay, means it's a methyl kind of thing. Only I replaced the hydrogen with tritium. then replace with deuterium, then it will continue with your CH3, then tritium, then deuterium, and then hydrogen. This will be your plus I. Even many more are there. So how many are you are going to write it? This is a somewhat your plus I effect or electron releasing group, okay, or electron donating group. So what is happening if suppose these groups are attached to a particular species, then we can say that it is giving plus I to that particular group for the stability or maybe for the reactivity. We will see when we will solve the example, then that time you can see what is the effect of plus I and what is the effect of minus I. Just this trend you have to write it down, but don't think that this is enough, right? We will solve example where the species will be more than this. Like here we have draw just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 species only. Even more than 15, more than 20 species are there where this electron releasing tendency order is following, right? So likewise, we have minus I effect, couple of functional group or element which follow the minus I effect. So minus I effect, it is like electron just opposite of this electron releasing. So electron withdrawing tendency, okay, electron withdrawing group, we can write electron withdrawing group or electron withdrawing tendency, right? So what will be the order here for electron withdrawing tendency? So first it is like, see, electron withdrawing tendency means when the electron withdrawing tendency will be more when the group or the species or the element will having scarcity of electron, and it is required from outer, like other bonded pair of atom, right? Other bonded atom, it will pull that pair of electron toward itself. So when we will solve the example, it will be more clearer over there, but here I will give you the sum of the range. It will be like O plus F2, okay, then you will have Nr3, then you have NH3. Okay, these are the order of plus I, minus I effect, and then you will have Cn, then you will have CHO. Okay, then you will have fluorine, then you have chlorine, then bromine, then iodine. Okay, likewise it will go there, and in at the last it will be hydrogen, right? These are the some trend of minus I effect, and when we solve the problem, that time you will find more of the electron withdrawing tendency group, which is attached directly to the ring or the molecule, okay, or the group. It will be directly attached. And please remember these concepts, okay. Actually, whatever this trend we are showing, either this one or this one, it is entirely depend upon your these concepts, like electronegativity, like more electronegative. I'll just write it here. If I'm talking about minus effect, here you have to see the electronegativity. If electronegativity is increases, your minus I effect tendency is getting increases. Okay, this line you just remember it. If electronegativity is getting increases, your minus I effect tendency is increases. Likewise, here you can write your electropositivity, or we can write that electronegativity decreases, your plus I effect is getting increases. Likewise, you can write here electronegativity is getting decreases, your plus I effect tendency is getting increases. So this all the trends is based on this. Like you have to find out the electronegativity. If electronegativity is getting increases, your minus I effect tendency is getting increased. If electronegativity is decreasing, your plus I getting increases. And how it will form, you have to just find out in that molecule whether it is sp or sp2 or sp3, right? Likewise, you have to find out that what is the bond angle, which functional group is attached to the particular atom, molecule or ring. You have to just see the bond angle of that particular group, right? Like suppose here O minus, here it is a negative charge. So this negative charge, what it will do with this oxygen? Because this oxygen is having negative charge, it means it want to be donated. Okay, this negative charge, this oxygen want to be donated. If this oxygen is want to be donated, means it is having plus I effect, because plus I effect electron releasing tendency or electron donating group. That's why it is kept in plus I, right? Likewise, it is having like OF2. Okay, this is like oxygen F, here also fluorine, and here positive charge. Now you just look it in that. Here fluorine it will withdraw. Here fluorine it is also getting withdrawing, right? Is having, because oxygen, in between oxygen and fluorine, we know that the electronegativity of fluorine is greater than electronegativity of oxygen. So what will happen? This bonded pair of electron will be shifted towards fluorine. Here also the bonded pair of electron will be shifted towards your fluorine. So now this oxygen will feel positivity. Though it is feeling positivity, it is having positive charge also, right? It is also having positive charge. Now what is happening? This oxygen want electron density, right? This oxygen want electron density. So what will happen? This oxygen will pull from this side. It will be heavily pulling by this side. So whatever group it is attached here, what will happen? This particular functional group, or this particular set of molecule, set of atom, it will pull from A, and how much heavily it is getting pulled, that electron withdrawing tendency we are showing here. So it will be very high, because here fluorine is also getting pulling, and your oxygen is having positive charge. So it is required from your the incoming, like whatever group is attached here, from there it will pull the electron density, and we say that it is having minus I effect here, right? So we will solve some of the examples, then it will be very much clear, or else it will be difficult for you. So few easy example we'll take first, and then we will move for the what is that, uh, like difficult examples. Like there is no difficult example, so we'll see that first. If you see, I'll just write down these examples. Suppose this is one example. Here you have O minus, and then you have this one OH, right? Now if I'll say which one is having, like which oxygen is having more, this oxygen will be here, oxygen minus. So this is species 1, this is species 2. Try to be understand that which oxygen will having more plus I effect. Okay, which oxygen will having more plus I effect? If I'll arrange the plus I effect order, and if you'll arrange the minus I effect order, how you are going to arrange it? So where there the oxygen is having minus charge, so how, what will be the tendency of this oxygen? It will try to donate it, right? It will be try to donate it. If it is donating, then it will be a plus I group. So here we can say that one will having more plus I, and then this two, right? How it came? Because here the negative charge is there. The negative charge means is this oxygen is having more of electron density, and if oxygen is having more of electron density, what it will do? It will just donate it. Okay, it will just transfer it. So if it is transferring, then we can say that it is a plus I group. Likewise, here also oxygen is there, but this oxygen is not having negative charge, and we know that this is carbon and this is oxygen. This is carbon and this is oxygen, and what is the electronegativity difference? Oxygen is having more electronegativity than carbon. If oxygen is having more electronegativity than carbon, what will happen? This oxygen will be pulling the electron pair towards itself, and this oxygen is pulling to the electron pair towards itself. Here we can say it is having minus I effect. So this one, if this one is plus I and this one is minus I, if we are writing plus I effect trends, then one will be more than two. If we write minus I effect trend, then your two will be more than one, right? Have you understood what I'm telling? If you are writing minus I effect, so this is having minus I effect, right? It is pulling, because oxygen is more electronegative than carbon. So the shared pair of electron will be towards oxygen. Here it will be delta negative, here it will be delta positive. This side it is completely different, as it is having minus charge, right? When it is having minus charge, again it won't take back from the carbon, right? It won't ask the electron density from this carbon towards oxygen. So what will happen? This negative charge, it will be the oxygen will be shifted towards the carbon, and it will be a play role like a plus I effect, and this will be a minus I effect, right? So maybe for you it will be an eye opener, but this is the case here, how we are finding the plus I effect and minus I effect. One example I'll see with the trend, I will take it. Suppose this is your like for example, I'll give remove it. Just example, you just solve it, try to solve it. This is one example I have written, and now I'm giving you questions. try to solve those questions, you will be master in this I effect, right? So suppose I'm giving you three examples. One will be like OH2 plus, this is A. Then I am giving you O minus. Then I am giving you OH, right? So just this is C, this is A, this is B, C. This. Just write the plus I effect trend. And these are the questions many times they have asked in NEET or your JEE Main or your state level, whatever the state exam is taking place. That state exam also it is asking. So it is very much needed. If you are studying any chemistry, any like if you are studying organic chemistry, whether it is for 12th standard or your UG standard or your master standard, so you need these basic concepts for inductive effect, electromagnetic effect, resonance effect, mesomeric effect. And please be with me. I will upload like every day some of the concept which will be really helpful for you, and you no need to pay anything for that. Okay, I will take your class for these concepts, and please try to be write down this concept in your notebook and revise it. And those who are master in this concept, you just go and solve some of the examples. Okay, uh, that will be benefited for you. I will share some of the examples as a Google document. So in this comment section, you will find that Google document, and please solve those questions. If you are able to solve those questions, it means your concept is good in this inductive effect. Whatever questions I am going to post in this under this video, it will be based on your inductive effect, and try to solve only by utilizing inductive effect. Okay, first, and when I complete all the concept like inductive effect, mesomeric effect, okay, and then your hyperconjugation and then your electromagnetic effect, then I'll give you full question where you have to apply all the concepts, whether it is based on inductive effect or hyperconjugation or resonance or electromagnetic, that you have to find it out, and based on that you have to say the acidity, basicity, okay, and stability, reactivity. So by the time you will be a master if you are practicing those questions and seeing this concept video lecture. Okay, if you know, you can skip this video lecture. If your concept is very poor, you can watch this concept and get the maximum benefit. So by the time I think you have solved this problem and what is the trend, you can just write it down, okay, in a comment box. I'll just mark this a question number one. Okay, so you just say that question number one, this is the trend. So now we will see what is the plus I effect. So plus I effect means it will be having electron releasing tendency, right? So electron releasing tendency, where we will see here the positive charge is there in oxygen. So this oxygen can't release because it is not having electron density. If the oxygen is not having any electron density, how it could be released, right? Here see the negative charge is there. Here it is neutral. So it means here the negative charge is there, means electron density is more. So it can donate. So it can donate. So in that trends, the B will be having more plus I effect. Then now from like now we have to see in between A and C. So when we are seeing in between A and C, what we could see the oxygen is having lone pair, so somewhat it can be donated, but we know that oxygen is not getting donated, oxygen is not donating, it will withdraw. But here we have to, the question asked for plus I effect, so we have to answer based on that only, right? We have to, you just don't think that it is having minus I effect, why we are writing in a plus I effect. So it is not like that. If question has asked based on plus I effect, you have to give answer accordingly, right? So here you have to see, you have to compare. Here it is a neutral and here it is a positive charge. So neutral is having somewhat electron which it can be donated, but positive is not having any electron density, so it won't be donated, though it will be taking back, right? So in this case, the C will be more stable, more I effect, and then your A, because A is having maximum electron deficiency in oxygen, so it can't be donated, right? So your trend will be BCA. Now you can just match your answer with this uh, whatever answer I have written, and then you see whether it is a correct or wrong. If it is correct, it is very good. Now directly you can go and take that those questions which is uploaded based on your inductive effect. You solve those questions, Okay. If you have further doubt, you can ask me in a comment. I will be like very much happy to answer your doubt. Correct. One or two examples more we will solve it. Let's see one ring type of question we will solve it. And that concept I told you I will discuss here only. So here it's a positive, and then here also it is positive, here also it is positive. So now you see, this is directly the deficiency based on the electron deficiency we have solved. This one is a ring size. This is question number 2. Here also A, B, and C. So now you have to tell me the minus I effect. What is the minus I effect trend? Okay, in this question you have to tell minus I effect. And one more question I'll give. This is third type of question, and this will be based on your what we could see one like we can tell based on bond angle. Based on bond angle, one question I'll give you. Based on bond angle, one question I'll give you. Wait, please solve this one. Question number 2. Based on bond angle, I'll give you one question. Okay, you solve this one. NR3 and then NH3. Okay, this is 1. This is 2. Which one is having more? You have to see that NR3 and NH3. This is a plus, so minus I effect you have to see here. So minus I effect, which one will have more minus I effect? I'll just write minus I effect trend you have to see. If it is a negative charge, then plus I effect we'll see. If it is a positive charge, we'll see the minus I effect. Because here positive means it is having electron deficiency, so it will pull, right? So minus I effect trend, you have to write it here, 1 or 2. Which one will be more minus I effect trend? So here in this case, minus I effect, how we are going to write here the minus I effect? Tell me. See, in this trend, how we are going to write it? See, one concept is there. The ring size, or the ring size, if it is getting decreases, what will happen? Your electronegativity is getting increases, right? If ring size is getting decreases, your electronegativity is getting increases. Hence, we can write it here. The ring size is decreasing. B is more, we can say that smaller ring size. So B will be your, here what will happen? Your I effect B will be more, then your C, and then your A, right? Your B will be more, then your C, and then your it will be A, correct? What about this one? This question number 3. See, if you are having doubt in this question number 2, you can directly contact me, okay, in a comment box. So we can further discuss how we have write this one minus I effect because the ring size decreases, the electronegativity is getting increases, okay. And if electronegativity is getting increases, so what will happen? There the minus I effect will be more. Okay, if more electronegative, then more I minus I effect. So then B will be having more electronegative than C, then A, right? So many time a question we can write it out, and you will find maximum questions which I am going to share it. So here, just tell me what is the minus I effect trend in this NR3 and NH3. Okay, just tell me. So here it will be like your second will be having more inductive, like your minus I effect than your first. Okay, second will be having more uh, minus I effect than your first, or the first is having more minus I effect or second. So here it will be first will having more and then your second. Okay, here your first will be having more minus I effect than your second. Though you can comment it here, it will like I know everyone will start commenting that here it will be like these are the donating group. Okay, these are the donating group. So here we are having somewhat electron density we are getting increase. If electron density is getting increase in nitrogen, it won't pull with that much intensity, right? So here the minus I effect should be less compared to this NH3. But the case is here if we are putting R group here, what is happening? Just see the bond angle here. The bond angle is what is happening. This bond angle is getting increases here. The bond angle is more compared to your anesthetic. Here bond angle is less, and we know that if bond angle is more, the first slide we are showing you the bond angle. If bond angle is getting increases, your percentage as character is getting increases. If percentage as character is getting increases, your electronegativity is increases. And if your electronegativity is getting increases, your minus I effect is getting increases. Now you just see here the bond angle is more. So what is happening? Directly percentage as character is getting increases. If percentage as character is getting increases, what will happen here? The electronegativity is getting increases. If electronegativity is getting increases, what will happen? Your minus I effect is getting increases, right? That's why this one is having more minus I effect than this anesthetic, right? Here the bond angle is getting played a role. Why the bond angle is more here? Because here bulky group CH3, here also bulky group, here is also bulky group. So these two bulky group, the repulsion will start, and then the repulsion, due to this repulsion, this bond angle is getting more. Okay, this bond angle will be more. If this bond angle will be more, then your percentage as character will be increases. Percentage as character directly relation with the electronegativity, it is getting increased, and then your minus I effect is getting increased, right? So these are the few examples we have solved based on the inductive effect. There are many examples are there. So what I'll do, all those example, I'll just write it down in a page and I'll share as a Google document. So you will find under this comment section, like not a comment section, in the information section of this video. Okay, below it is there. So you just go through that. It will be freely accessible. You just go and download it and you just solve it. Okay, you solve those questions. Okay, solve those questions, and how you are going to check whether those are correct or not. Solve those questions and you send it to me. Okay, in this you will see the WhatsApp number. Okay, WhatsApp number. In that you send it to me. I will go through with that questions. You just write it down. If you want, you can write it down the examples like reason also how it is correct or wrong. Let me write down the number, which WhatsApp number you are going to search. 1 second. It will be your 799-234-2768. So in this number, you just send me. Here the WhatsApp number is there. So in this number, you send me your solution, right? All those solution you send it to me. I'll go through, I'll check it, and then uh, I'll tell you whether it is where the problem. If maximum problem I'm getting, if you are unable to solve, then what I'll do next class I'll take and I'll solve those problems for you. But it is not the solution. The main thing is you have to solve those questions. And I know whatever the concept I have given you, it is more than enough for you to solve those questions. It will be easily, it will be solvable, right? So again, I'm telling this inductive effect class. Next, I'll take electromeric, then hyperconjugation. Okay, then resonance I'll take. So these are helpful for your 11th class, 12th class, NEET. Like wherever the chemistry is there, it will be helpful because without these, your chemistry won't grow. You can't like directly you will see the reactions and then you are starting memorizing those reactions, right? It won't be like that. If you know the inductive effect, electromeric, like this electronic displacement, four type of electronic displacements are there. If you know these, you know the reactive intermediates, right? Then your chemistry, organic chemistry, you will find somewhat commanding. And after getting these concepts, okay, and proper revision of these concepts, yeah, you will see the difference between you, like previously how the organic reactions you were seeing and now what is the difference, like how you are seeing the organic chemistry, the reactions. Now it is very much easy to understand the reactions, how it is happening after this uh, electronic displacement and reactive intermediates. You will see the difference. Okay, so for today's class it is this much only. So thank you very much. Okay. Thank you all to attend the class. Okay, thank you.